Welcome to the lecture for section 6.2, Applications of the Normal Distribution. Let's begin by reviewing how to compute a z-score. If you're given a data value, you subtract the mean from that value and divide by the standard deviation. Let's look at example 1. Example 1, let's review some more. Adult IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. Find the probability that a randomly selected adult has an IQ score that is less than 120. Let's first do this by converting 120 to a z-score. I started with our value of 120. I subtracted the mean and I'm dividing the entire thing by the standard deviation. Using your calculator, you will end up with 1.33 infinitely repeating, and I'm rounding that to 2 decimal places, so that would be about here. And we want to know the probability that a z-score is less than this value. So that's this left-hand side. And the area here will give us this probability. In your calculator, you would use normal CDF. So our smallest value is here. That would be towards negative infinity. And our largest value is 1.33. So on your calculator, you would type in the mean is 0 and the standard deviation is 1 since we're using the standard normal curve. Your calculator should give you about and before I round, let's do this problem again without converting to a z-score. So start with our mean of 100, add 15, and add it again, and again. And now go ahead and subtract 15 3 times. 120 is about here, a little bit closer to 115 than it is to 130. And of course, we're interested in z-scores here, with IQ scores that are less than 120 on the left. And that would be given by this area that I shaded here in pink. So on your calculator, you would enter Now, if we round these to 1 decimal place, they're both about 0.91, so they're identical. If we round them to 3, we're pretty close. Let's look at part B. What percentage of adults have IQ scores above 140? Again, let's start by converting 140 to a z-score. So that would be here. And again, we'd use normal CDF to find the area in that rightmost tail. And after entering this on your calculator, you should get Now, let's do this again, but instead of converting to a z-score, start with 100 in the middle again, and add 3 standard deviations on the right and subtract up to 3 standard deviations on the left. want the probability that a z-score is greater than 140, so that's this tail. Not a z-score, excuse me, an IQ score. On your calculator, you would enter and in this case, if we round to 4 decimal places, we have identical answers. Let's turn to the top of the next page and continue our review. Find the probability that a randomly selected adult has an IQ score between 95 and 105. Let's convert both to z-scores. So we're interested in IQ scores, or z-scores in this case, between negative 1/3 and positive 1/3. And that will be given by finding this area will yield that probability. On your calculator, enter and you'll get now we can do this without converting to z-scores first. I'm interested in z-scores between 95 and, IQ scores between 95 and 105. It's really easy to constantly mix up IQ score and z-score, at least in words. So this probability will be given by that area. And if you round to 2 decimal places, we end up with identical answers. Finally, let's find the third quartile. That is, we want to find the value that separates the bottom 75% from the top 25%. So I'm going to guess that this would be the third quartile, third quartile. And this is one we've done before, if you recall. We're looking for this. So this z-score will be given by inputting this area, or this probability, into an inverse norm on your calculator. So I know that the probability that z is less than 0.67 is about 0.75. And I rounded here, so this is no longer going to come out to exactly 0.75, but we'll get close. Let's do this without converting to z-scores. So the 75th percentile is going to be about here. Let's label this B this time. And again, we know the area on the left we want is 0.75. So on your calculator, use inverse norm again. That's pretty close, about 110 would be the IQ score, separating the bottom 75% to the top 25%. If you notice here, we don't really have an IQ score. So let's convert this to an IQ score. So our z-score, I'm going to just type in or write in the rounded version, but you should use the unrounded version on your calculator. You notice we get identical IQ scores for both. Example 2, juice bottles. Suppose a company makes mango juice in 12-ounce bottles. There's some variation, however, in the amount of mango juice dispensed using their auto-filling machine. The amount of each bottle is approximately normally distributed with a mean of 12 ounces and a standard deviation of 0.042 ounces. What is the probability that a bottle contains less than 11.9 ounces? So let's not convert to a z-score. Let's start with our mean of 12, and we're going to add one standard deviation to 12 3 times. And we'll subtract it as well. So here is 11.9 about. And we want to know what the probability that a bottle of mango juice will have less than 11.9 ounces. And that will be given by the area under that curve, which we will find by using normal CDF on our calculator. So on your calculator, you're going to go to second, vars, and then scroll down to number 2, normal CDF, and you'll enter to end up with and rounding, you end up with about so less than 1%. The probability that a bottle contains less than 11.9 ounces is 0.86%. Let's look at the top of the next page for another example. Example 3. Aircraft engineers want to design seats in commercial aircraft so that they are wide enough to fit 99% of all males. Men have hip breadths that are normally distributed with a mean of 14.4 inches and a standard deviation of 1 inch. How wide should the seats be to accommodate 99% of all males? So let's start with the mean. And add 3 standard deviations. And then subtract on the left 1 standard deviation at a time until we're 3 standard deviations below. So if we want to accommodate 99% of all males, we're going to need some A value all the way out here. And we know we want 99% of the area on the left. And that's going to be found in probability notation, this looks like the probability that x is less than a is about 0.99. And to find a, you use inverse norm. The area on the left is 0.99. Our mean is 14.4. And our standard deviation is 1. And that's going to give us and let's round, that's about 16.73 inches. Seats should be about 16.73 inches to accommodate 99% of all males. And on our picture, this would be about here. So we are pretty close with our guess. Let's look at example 4. Birth weights in Norway are normally distributed with a mean of 3,570 grams and a standard deviation of 500 grams. If this hospital in Oslo requires special treatment for newborn babies weighing less than 2,700 grams, what is the percentage of newborn babies requiring special treatment? So let's start off with our mean here in the middle. And add up to 3 standard deviations on the right and subtract down to 3 standard deviations less on the left. Often, and that's more of an aesthetic choice because otherwise it'd be a little too crowded in. Now we want to know the probability of a baby weighing less than 2,700 grams. Where's 2,700? That would be about here. In probability notation, that probability is given by the area under this curve. And we will use normal CDF on our calculators. To get so about as a percent, that's so the percentage of babies newborn babies requiring special treatment is about 4%. Example 5, tall clubs. Tall Clubs International has a requirement that women must be at least 70 inches tall. Given that women have normally distributed heights with a mean of 63.8 inches and a standard deviation of 2.6 inches, find the percentage of women who satisfy this height requirement. So take a moment and complete this one on your own. I'm going to pause my recording now, and when you see the recording again, the solution will be filled in completely. But you should take a moment and try to solve this one independently before continuing. Your paper should look like this. If you notice, I have my mean here, and I've added 1 standard deviation 3 times on the right, and I've subtracted 1 standard deviation 3 times on the left. This is labeled with heights of women in inches. We use normal CDF to find this probability, to find this area in this tail here, starting at 70. Our mean is 63.8. Our standard deviation is 2.6. Your calculator should give you this value. So the probability of x being greater than 70 is about 0.0085 or about 0.85%, so less than 1%. About 0.85% of women satisfy this height requirement. This concludes the lecture for section 6.2.